Example 6. In example 6, we're going to look at when there's the form of 0 times infinity. This is a problem because infinity is a vastly large number, but we know that anything times 0 is going to be 0. So when we have 0 times infinity, we actually can't tell the behavior of the function. So what we're going to end up using is reciprocal substitution. Remember, this is when we replace positive infinity with 0 from the right, or 0 from the right with positive infinity. So in example A, we're going to look at the limit as x approaches infinity of x times sine of 1 over x. Now if we were just to use a direct substitution for this problem, we would get that this is equal to infinity times sine of 1 over infinity. And this would give us infinity times sine of 0, which is going to be infinity times 0. So that really doesn't tell us anything, so we're going to look at a different function to get the answer. So remember, with reciprocal substitution, we do the limit as x approaches. Because it's infinity, we're going to use 0 from the right, and then the x becomes 1 over x, and this becomes sine of 1 over x, or 1 over 1 over x, simply just becomes x. So this is the limit as x approaches 0 from the right of sine of x over x. Now we know this limit. We know that the limit of as x approaches 0 of sine of x over x is 1. But let's actually look at why it's that way. So if we plug it in, we get 0 over 0, which is a problem. But then we can use L'Hopital's rule. And this becomes the limit as x approaches 0 from the right. The derivative of sine is cosine of x, and then divided by 1. So this becomes the limit as x approaches 0 from the right of cosine of x. So then we can use direct substitution, and we get cosine of 0, which is equal to 1. We're going to do the same thing now, but we're going to look at this as we approach negative infinity. So because we see the negative infinity, we're going to go ahead and use our reciprocal substitution. So this is the limit as x approaches 0 from the left of 1 over x sine of x, which we saw to be the limit as x approaches 0 from the left of sine of x over x. And then using L'Hopital's rule, we get that this is the limit as x approaches 0 from the left of cosine of x, which is just equal to 1 again. Okay, now on your own, I want you to try to determine the limit as x approaches infinity of x times tangent of 1 over x. Alright, so the first thing we're going to try to do is a direct substitution. But if we do that, we're going to get infinity times tangent of 1 over infinity, which is 0. And this is going to give me infinity times 0. So again, that really doesn't tell us anything. So we're going to have to use something different. And whenever we have infinity times 0 or 0 times infinity, we're going to use reciprocal substitution. So this is going to be the limit as x approaches 0 from the right of 1 over x times tangent of x. So this is the limit as x approaches 0 from the right of tangent of x divided by x. So if I try to do a direct substitution here, I get this is tangent of 0 divided by 0, which becomes 0 over 0. What this means is I get to use L'Hopital's rule. So using L'Hopital's rule, we get this is the limit as x approaches 0 from the right, and the derivative of tangent is secant squared x divided by 1. So this is the limit as x approaches 0 from the right of secant squared x, which is just going to be secant squared of 0. And so I'm going to rewrite this as 1 over cosine squared of 0. So I get 1 over 1 squared, which is just 1.